Hi Engineering Janta, I am Vaibhav Shukla and today we'll understand the limitations of queues. This is another video in the free DSA series that we are building for you so that you thrive high in your career. So why are we talking about it? Why are we talking about the limitations of queues? So before I dive in deep into the limitations of queues, it is essential to understand that after this we are going to study circular queues where you'll find the usage of this percentage symbol somewhere. Fine. Now in many cases on many websites on internet, people have used this symbol in the normal implementation of queues as well, not the circular queues. In the normal queues as well, they've used it. And essentially, it is important to tell you that in the interviews, when interviewer knows well about queues, he grills you over this if you're using it. Also, with this, the limitation of queues is associated. When we'll learn circular queues, you'll even get a better understanding. Right now, you'll know what exactly the shortcoming of queue is, or sometimes it might prove beneficial as well. That shortcoming might prove as beneficial as well. Fine. So that is what we'll try to understand, and this is the same code that we've used in the last video. Exactly same code, zero changes. So if you're somebody who hasn't watched the previous video, I strongly suggest please watch that video first. Otherwise here you'll not understand anything. Fine. Now coming to the limitation portion, consider a queue and for a while ignore this big size, just consider the size of queue is 5. Fine. So in that case we'll have a queue which has 5 as its size. So somewhere like this, 0, 1, 2, 3 and 4 can be the indices, and it can store 5 elements. I do these operations on it. See, NQ 18, NQ 17, NQ 19, NQ 30, and then I do DQ. Again I do DQ. So if I start implementing these particular functions, what will happen? First, INQ 18, so 18 comes here. INQ 17, 17 comes here. INQ 19, 19 comes here. INQ 30, 30 comes here. Fine. So after this NQing, I am saying that I am doing the DQ operation. Now, for those who have watched the last video, they know that whenever I DQ, I assign that particular block of memory -1 as the value. What I am trying to say is, basically if I DQ now, so first element that would go out is 18. Fine. So when it gets implemented, this is all implemented and this also gets implemented. Now 18 is out of the queue and you have -1 in its place. It has been replaced. That's how DQ works in my code. Fine. Now I again do the DQ and again the similar thing happens. Fine. And this is also executed. Now rear is pointing here. Fine. Front is pointing here. Front PT and rear PT were two pointers that we use. Fine. Not here. Pardon, front is actually pointing here now at this particular location. Fine. So 19 is the front. Now in this case, if you carefully see, if I do one more NQ, I do NQ. Fine. And I write 20. Fine. So what will happen? 20 would enter here and this rear PT would get incremented. Fine, it would go somewhere here. The value of rear PT is incremented. Now in this case, if I try NQing one more element, which is, I say 11. Fine, if I try NQing 11, now there's a problem. Why? For NQing, what we were checking initially, for NQing, we were checking whether the rear pointer is equal to size or not. So here size was 5 and rear pointer is actually right now rear PT is 5. So this particular condition stands true. Hence, it would print Q is full. It would print Q is full. Is it full? The question is it really full? No, it's not. Because we have these places where we can store something. This is -1 that I have put for my reference. Otherwise, I can simply erase all this. Fine. I can simply feel that these are empty blocks of memory and these are being wasted, isn't it? I cannot add anything here. Now, the capacity of Q is 5, the size of Q is 5, but actually it is holding only 3 values and still it is saying that it is full. Fine. So, in this case, this is a limitation that we encounter while implementing queues. Now, for handling this limitation, one thing we did was, when I start dequeuing, fine, I do further more dequeues. This has been implemented and then I do further more dequeues. Fine. So, dequeue happens, again dequeue happens and dequeue happens. Fine. So, in this case, all of the 3 would be replaced by -1, isn't it? So, all of them are now -1, -1, -1 and -1. And this front PT would get incremented and it would point at same index where rear PT is pointing. Whenever this happens, we had specifically made this that you reinitialize the front pointer and rear pointer. So, basically, whenever this happens, you make them reach here at the initial positions. So, now in this case, what will happen? This pointer of front and rear would reach here. So, rear would also point here, rear PT comes here, front PT comes here. We had done that. We had done that earlier so that we can again start from the first value, first index, and we can begin writing it afresh. But had there been a few values till end, we would not have been able to enqueue something, and that is a limitation that queues offer. Now, how can this limitation turn into a boon? Why it is also helpful at times? For those who have studied OS, great, you will understand it more. For those who haven't, I'll make sure you understand, so don't worry. समझ सबको आ जाएगा, ठीक है? Point is, whenever your computer is trying to execute few processes, fine, in any operating system, when it is trying to execute some processes, sometimes it wants a queue, a line of processes that comes. And then at times, you want your operating system to be idle for a while. You want it to execute a particular batch of processes and then go to the next batch of processes. Fine. That was used earlier in the batch operating systems. Fine. So, in that case, you need a few batches. Fine. For that, say I want a batch of 5. In that, unless all the 5 processes have been executed, no new process would enter the queue of execution. For example, what I am saying is, consider this is the queue of execution order, fine, of processes, fine, and you have P1, you have P2, you have P3, you have P4 and you have P5. These are 5 processes that you have, fine. So, for these 5 processes, what would happen? Now, if you're trying with these 5 processes and these 2 processes are completed, they'll simply get dequeued, isn't it? But your operating system wants that no new process should enter until the whole batch of 5 is fully executed. So, in this case, queue will show that queue is full, hence nobody can get enqueued. So, hence, till you execute this process, fine, then you complete this process and then you complete this process. In this case, according to our implementation, front PT and rear PT would be lying here, right, after the execution of all processes. Now, they'll be reinitialized to this position. Fine, they'll be reinitialized here, and then you can execute the fresh batch. Fine, so this is the benefit that this limitation offers, or it used to offer. At some places it still offers this benefit, but in the truest sense this is a shortcoming. Fine, this is not the most effective usage of memory, so that's why it is called as a limitation of queue. And that's all about this video. It's pretty much about the video. But why is it essential? Because this is often asked in interviews. Interviewers grill you when you use simply the percentage symbols and you don't know why or what exactly the limitation was behind that. Fine, so you need to understand that. So henceforth, if you have any doubts regarding this, do tell me in the comments, because top 3 comments may stand a chance to win Prep Insta Prime subscription. And very soon I'll be announcing giveaways. I have done that earlier. I correctly remember the name. The first user that got recently was Janvi Gattu, and then it was Farheen, if I'm not wrong. So these were the 2 names, and very soon I'm going to announce more names for giveaways. Fine. And if Farheen and Janvi, if you've missed those videos, please go check the DSA playlist. You're having your names as the giveaways, so go ahead. You have chance to avail the 3 months free subscription of Prep Insta Prime. You have won that in the contest that we regularly run. And follow us on these social media handles so that you never miss any hiring update from our side. Fine. So whoever needs this knowledge, as I always say, go ahead, spread it, keep doing good. Good will come back to you.